Hello again. Welcome to a unit on one of the most hated things in math, the fraction. We're going to try and reduce some of the hate on fractions because they haven't really done anything wrong. And the way we're going to go about that is by trying to understand them properly. You may have done a bunch of math in your life, dealt with a bunch of fractions, but never really understood what they are. Or maybe you have. Maybe they're not a problem for you, in which case that's great. But let's go and look at what fractions mean and some of the ways to convert them in this video. The first thing that we'll look at is what a fraction actually means. When I write something like 1/3, there are a couple of mathematical properties that are really important to take a look at. When we have a number like 1/3 or 1/3, what it indicates visually is containing 1 out of 3 parts. So we've got a shape that's been divided into 3 parts. That's what the bottom number always tells us. How many parts is our shape divided into? And the top also always tells us how many of those we are indicating. Another really misunderstood part about fractions is what the fraction bar means. A lot of people, I would think, just ignore it, but it's actually a division sign. Okay, so that actually means 1 divided by 3. If you try that on your calculator, you will see that your calculator gives you the result 0.3 repeat. That decimal there is equivalent in value to what 1/3 is. So here's an important piece of information to understand, that fractions are just another way of writing a decimal, right? Which is just another way of writing a fraction. They all indicate values that are between 0 and 1, so less than 1 whole. The 3 types of fractions that we're looking at in this first section, we're trying to identify what's a proper fraction, what's an improper fraction, and what is a mixed number. So let's break down what that means. It's pretty easy once you understand what's happening, and now that we kind of understand what fractions are and what they're doing. So any proper fraction has a smaller number on top than it does on the bottom. What we'll soon learn is that means that a proper fraction is somewhere between 0 and 1, right? So it's less than 1 whole. There is one technicality on that point, and if we look over here at question E, you'll see what it is. I previously mentioned that it should be the smaller number on top and the larger number on the bottom. There is one other case, is where if you have the same number on top and bottom, I guess you could consider this a proper fraction as well. And the reason that this is a special case, because if you were to calculate 7 divided by 7, the result would be 1 whole. Then we look at improper fractions, and we look to see, and you'll see the same pattern all the time. The number on top is larger than the number on the bottom. What this actually indicates is that we've got a number that's more than 1, probably with a leftover part. And what I mean by that is if you divide 4 by 3, you'll find that it is 1.3 repeat on your calculator, right? So this is a number that's larger than 1. We consider anything with a larger number on top than on the bottom to be an improper fraction. Improper fractions can be written as mixed numbers as well. If we look at this example here, the improper fraction 4/3 is actually exactly equivalent to 1 and 1/3. We'll learn how to do this shortly, but for now, I just want to, break down what this term mixed number really means. And the reason that it's called a mixed number is because you're mixing together a whole number part and a fraction part. And 1 and 1/3 is the mixed number we're looking at here. If we were to convert this number on a calculator or using short division, we would again get the result 1.3 repeat, just like we did in the previous example. So improper fractions and mixed numbers are closely related. They're 2 ways of saying the same thing. So the next section talks about Well, it says write the decimal form of each of the following fractions. What it's talking about here is we're actually converting a fraction to a decimal. Well, the easy way to do this is to punch it into a calculator. We understand that fractions and the fraction bar mean division, so this means 1 divided by 8. Your calculator will give you the result, 0.125. The question is, how did that happen? And let's use our division skills from the previous section in order to calculate this. So what we see is 1 divided by 8, and when we rewrite this as short division, the number you're dividing by always goes on the left, and the number you're dividing into goes on the right. What you'll notice is 8 is not going to fit into 1, so I'm going to have to add a decimal place and a few zeros as placeholders so I can do this type of division. And we'll say 8 goes into 1 exactly 0 times. So we're going to have to try again. And the next part that we look at is, does 8 go into 10? And it certainly does. It goes in 1 time. This is the short division skills. 1 times 8 is 8. We were aiming for the number 10, so we missed it by 2. In the next column, I carry that 2 over. We're now trying to put 8 into 20. And 8 into 20 is going to go twice. 2 times 8 is 16. I was aiming for 20, so I missed it by 4. So now I'm going to try and put 8 into 40. And 8 goes evenly into 40 5 times. 8 times 5 is 40. I didn't miss it by anything, so I am done. I now have the decimal version of what a fraction is. A lot of people are probably wondering at this point, well, if a fraction and a decimal can represent the exact same thing, and then what's the point in having a fraction if you could just convert it to a decimal? I'm going to answer that quickly right now. If we look at a number like 2 over 3, and if we were to do the division for it, we would see, whoops, that's a 0, not a 9, we would see that 3 goes into 26 times. 3 times 6 is 18, which gives us 2 left over. Well, 3 into 20, that goes 6 times. Okay, so we're going to have to keep going here because we keep getting the same thing. There were 2 left over. 3 into 20 goes 6 times. There were 2 left over. And now what you're seeing is that this could go on forever. This will, in fact, never change. So most people at this point will say, oh, well, I'll just round it to 2 decimal places, which is a great skill to have. But 0.67 is very different than 0.6 repeat, which is very different from 2/3. So the story here is, when we're talking about strengths and weaknesses, the strength of fractions is they keep exact values without having to round or estimate, so we don't lose any information. The strength of decimals is that they're really good at comparing values. Let me give you an example of that. So if we were to talk about test scores, would you rather get 16 out of 21 on a test, or would you rather get 45 out of, I don't know, 53? And which score do you think is better if you're trying to get the higher score, which I would assume you are? Well, this is a really hard thing to figure out. So what we would need to do is we would need to convert these to decimals by dividing them out, and the decimals would give us a much easier value to compare, and that's the benefit of using decimals. That's their strength. So just to recap, fractions are really good at being exact and not losing information. Decimals are really good at comparing numbers together. Each of these has tons of other strengths and weaknesses. We'll get into that as we move along. What we've talked about so far should now give you enough information to be able to make an argument about why 1/8 and 8 over 1 are different. So we're going to move on past there. The next section that we look at looks at converting improper fractions. So remember, we've got a larger number on top than we do on the bottom. So we're going to convert this improper fraction into some kind of mixed number. So we need a system to do this. If you remember, I've said it a few times now, the fraction bar is actually a division, right? So the long way to convert would be to do this as a division question. So let's do that right now. Whoops. There we are. So the bottom number goes on the left. The top number always goes on the right. And let's see what we get. So 3 into 5 does in fact go once. You'll notice that this improper fraction that's larger on the top than the bottom is in fact above 1. And so let's keep going. 3 went into 5 one time with 2 left over. 3 goes into 20 6 times. 3 times 6 is 18, 2 left over. 3 times 6 is 18. We were aiming for 20, so there's 2 left over again. And we get the same thing that happened before. We get a result of 1.6 that continues to repeat. This is the decimal version of this, but that's not what we were looking for. So I'm going to go back here a little bit. To get the improper fraction, we're actually just going to use the remainder. Okay, so we're going to go 3 into 5, which in fact does go one whole time. The remainder is 2 out of a possible 3, which is the number. Okay, so the remainder was 2. That's because 3 goes into 5 once with 2 left over. And then the number we were dividing by can always go on the bottom of the fraction. And the result, as you can see, that we're left over with is 1 2/3. Now this might be what you would consider a trickier way to do it, using full division. So I'm going to show you a simpler way which maybe you've seen before. We take a look at a new fraction, 5/4, and we'll do the same process. We're not going to rewrite it as a division like we did up above. We're just going to do the division in our head. So we're saying 4, how many times does it go into 5? Well, it goes in once, and we've got 1 left over, right? Because 4 times 1 is 4. We were aiming for 5. The remainder is 1. We keep the same denominator or bottom of the fraction as we used before, and 5/4 nice and cleanly converts to 1 1/4. It's fine. Sometimes you need to use full long division depending on how large and complicated the numbers are. I'd like it if you can get to the point where you can do it this way with this system and just directly convert the improper fraction over to the mixed number. So we move on logically to the next section where we're going to do the opposite operation. We're going to convert mixed numbers here into improper fractions. So I will use an example like 1 and let's actually go 1 3/4. This mixed number, again, it's a mixed number because it's got a whole number part and it's got a fraction part. And there's a system that will allow us to convert this into an improper fraction. And if I zoom in a bit here, I'll be able to show you. What you're going to do is you're going to multiply 4 times 1 to get to be 4, and then you're going to go in this direction here, and you're going to add the leftover parts that are on top. So 4 times 1 is 4, add 3 is equal to 7/4, and that's all there is to converting mixed numbers into improper fractions. Question 6 asks why you cannot convert 6/23 to an improper fraction, so I'll let you think that one through. As we move on to the next section, which is going to be about reducing fractions, I'm hoping you're getting a better sense of what fractions are, what they mean, and how to use them. If you've done each of the practice questions, you're probably in that situation. So I'm going to reduce the fraction 2/4, which might seem pretty obvious, but I'm also going to visually reduce this. Okay, so what we're looking at here is 2. Whoops, line went a little outside the box, that's okay. 2 out of a possible 4 parts is what we're looking at. Okay, so as you can see, this is about half the information. Or I guess half of the total amount would be a better way to say it. Yeah, we've got 2 out of a possible 4 parts. And if we were to remove the division lines there, and I'm just going to redraw this thing a little bit better. There we go. If that's our halfway point, what you'll notice is that 2 out of 4 basically represents, or not basically, actually represents half of the information. So 2 out of 4 could be reduced down to 1 out of 2, which is a half. But obviously there needs to be a mathematical way to do this. And what we do mathematically is we look at the number 2 on top and the number 4 on the bottom, and we try to figure out what is the largest number that I can divide 2 and 4 by. And it has to be the same number, so you'll hear this a bunch. You have to do the same thing to the top of the fraction as you do to the bottom. The reason is, otherwise you're changing its value. If we were to divide 2 by 4, and we would get 0.5. And if we were to divide 1 by 2, we would also get 0.5. So here we have two fractions with the same value. What we're trying to divide 2 and 4 by should be, well, the greatest common factor. Remember that from the last unit. The greatest common factor of 2 and 4 is 2. So that's what we can divide the top and the bottom by. 2 divided by 2 equals 1, and 4 divided by 2 equals 2. And as we demonstrated above with the decimal equivalent, 2 out of 4 is the exact same thing. Well, maybe exact's the wrong word. 2 out of 4 holds the same value as 1 out of 2. The next example we look at tells us how to deal with larger numbers that we're trying to break down. It would be really nice if we could figure out what the greatest common factor between 60 and 100 is. And there are ways to do that, but realistically, maybe you're just going to try and break this fraction down in a couple of different steps. So if we were going to do this in a couple of different steps, I might look at 60 over 100, and I might be able to see that, oh, yeah, well, they both end in 0, so maybe I could divide the top and the bottom both by 10. That's going to get me 6 out of 10 when I divide it out. The next thing I notice, well, 6 out of 10 is not in its lowest form because there's still a number that both you can divide into both 6 and 10. Well, they're both even numbers, so, oops, I could divide 6 and 10 both by the same number. It always has to be the same number. Divide them both by 2, and I end up with 3 over 5. And 3 over 5, let me just try and clean that 5 up a bit. 3 over 5 is actually now the fraction in its lowest form. And the reason that I know that is because there is no number that will divide equally into both 3 and 5. A connection that you might make at this point is noticing that we first divided by 10 and then we've later divided by 2. It's no coincidence that 10 times 2 is equal to 20. Let me show you why that's not a coincidence. 60 over 100, if I was to divide it by its greatest common factor, which happens to be 20, 60 divided by 20 is 3, and 100 divided by 20 is 5. We could have got there in one step, but this was a fraction that was a little tricky to figure out what the greatest common factor should be. So there's nothing wrong with doing it in multiple steps, if that's how you need to do it. As I said, there are other techniques to do that. You can search the internet for those if you like, and we looked at some of them in class. As we continue to learn more about what fractions actually are and how to work with them, you'll notice that this video is quite a bit longer than some of the earlier concepts we covered in the other units. The reason is, yeah, fractions are pretty complicated. There's a lot to know. So the next skill is taking a decimal and turning it into a fraction. And for this, we just have to understand our place value, and we have to understand how to reduce a fraction, and then we're going to be done. When we look at the place value for these, this is the ones column, and this is the tenths column, right? And something that each number that's in the tenths column holds a value of 1 over 10, which would be equivalent to 0.1, right? So we're looking at 0.4 over here, I realize that. But at its lowest form, 0.1 is equal to 1/10. That's the 10th column. So converting 0.4, or 4/10, into a fraction is as simply as writing out 4/10. That's it. That's the fraction, that's the amount. 4 divided by 10 is going to be equal to 0.4. Now, of course, there's more to the story because, well, working with fractions and math in general usually has a lot involved in it, right? So what we're going to do now is to try and reduce this fraction that we have here. So the skill that we just previously learned, what's the biggest number that divides into both 4 and 10? Well, it's an even number, so let's see. 2/5. Yeah, 2 over 5. That should work because there's no number that divides equally into 2 and 5. So that is now our fraction in lowest terms. So once again, we started with 0.4. 4/10, if you divided that on a calculator, you'd get 0.4. So that answer is in fact correct, but what's considered to be a better answer is the fraction in its lowest terms. The reason that we put fractions in their lowest terms is because, well, let's just quickly look at this example. You got a pizza, it's split into 6 pieces. If there's 3 of them left and this pizza is sitting in a box, if somebody picks it up and offers it to somebody else, they're going to say, hey, do you want a half a pizza? I don't think I know anyone who would say, would you like 3/6 of a pizza? That's just not how people talk. So people speak in lowest terms, and people also speak in mixed numbers. They do not speak in improper fractions usually, right? I also don't know anyone who would give me 3/2 of something. They would generally give me 1.5 of something. So as we're working through any of these fraction questions, there's a couple of conditions that you should make sure that you meet. First of all, your fraction should be in lowest terms, so not 3/6, it should be a half. And also, not only that, it should be written as a mixed number rather than an improper fraction in your final answer. The reason is that's the way people speak. The last small section we have here, hopefully you have enough information to tell us what an equivalent fraction is at this point. If not, I'd suggest look it up on the internet and see what you find. And then we have one more section before the end of this video. Now, we said one of the strengths of fractions is not losing information. So you don't have to do any rounding if you convert it to a decimal like we would have to with 2/3. Now, what fractions are not good at is comparing which is smaller, which is larger, right? Remember when we went back to the test score, it was really hard to see which was the better test score until we convert them to decimals. So that's exactly what you should do here. If you want to figure out what is the highest number, what is the smallest number and what is the largest number, the best way to go about it that I could think of is to convert these into decimals. There is another way to do it, of course, because in math there should be multiple ways to do pretty much anything. You could also convert these to equivalent fractions, so you could get the same denominator for each, which would change each fraction's numerator. And if you created equivalent fractions, then you'd be able to quickly see which fraction is the largest and which is the smallest.